Simplify this expression completely. Well, let's see, what can we do? This in here is addition, so I guess we could just go ahead and combine like terms. As far as the bottom part, so this one, to be honest with you, I didn't make up this problem, but I found it someplace else, and I thought it was good because they're trying to be tricky. What they're trying to do is trick you into canceling right now. Because you look at this x squared plus x and you think, oh, I can cancel that. But the top part has two terms, this one in parentheses and this one in parentheses. So the only way that you could cancel it is if it shows up in both sets of parentheses. So you can't cancel it. So we need to instead actually, I think we should start factoring, because we need to factor this and find out what each piece is made of. Once you have the top factored, then you can start canceling. So let's see, what could we factor out? From this we can factor out an x squared. From this we can factor out an x. So this one first. So from this one you can factor out an x squared. He leaves behind x plus 1. So that's for that guy right there. Then there's the plus. And from this one, you can factor out an x. He leaves behind x plus 1. Let's see. From this one, we could factor out, so this set of parentheses, you could factor out an x squared. And it'll leave behind x plus 1. But instead of having that plus in between, this has multiplication in between. So from this one I could factor out an x, but it's just going to be sandwiched right in there. And then when you factor that out, there's x plus 1. So we still need to keep factoring because this one still has a plus in between that's still one term plus another term. And I don't want to start canceling until I have this factored completely. So notice, out of these two terms, this one has an x plus 1 and this one has an x plus 1, so we could factor that out. This one has an x and this one has an x. So that's what we would factor out next. So you can factor out an x, you can factor out an x plus 1, and then what's left behind, let's see, from this term, the x plus 1 got factored out, one of the x's got factored out, it leaves behind an x. Then this whole thing got factored out, which means that there's a plus 1 that's left behind. Aha! Now that it's factored, I'm just recopying the bottom without even really thinking about it. Now that it's factored, now we can cancel. So there's an x plus 1 here and here. The fact that this one had square parentheses or square brackets doesn't matter, it's still a factor, so that can cancel. The same here. And the same with x. 1x will cancel 1x. So, for what left on the numerator, there's just the number 1. And for the denominator, there's just this x squared. And then that can be simplified even more because you could take the square root of 1 is 1, and the square root of x squared is x. That's pretty amazing that that big thing right there can be simplified to just be square root of x. Math is incredible.